Hey guys, it's Mr. Thomas here. I just wanted to make a quick video illustrating how to do a couple of the problems from the last Bergen County Math League contest number 2. Today we're going to look at 2.2, how to factor this perfect cube. 2.5, how to find the value of x that satisfies this, and 2.6. And remember, these are all no calculator questions, so it's important to be able to do these without the calculator, and I'll show you how to do that as well. So let's go to the first problem. The first problem here says that this is a perfect cube. Since it's x to the 6th, that means it's going to factor into ax squared plus bx plus c all raised to the 3rd. For me, it's easier to think about this as ax squared plus bx plus c times itself 3 times. There's a few things we want to look at when we're doing this. First of all is this first term, 27x to the 6th. For this to be a perfect cube, that's going to have to be 3x squared, 3x squared, 3x squared, so that if I were to FOIL this out, I would get 27x to the cube. The other thing we want to look at is on the other side, that negative 8. Same thing. If I want that to be negative 8 when I multiply the last terms, negative 2, negative 2, negative 2, that's how I'm going to get my negative 8. Now, if you really wanted to, you could FOIL all of this out and distribute and combine like terms and all that. That's a lot of work. So instead, we're going to focus on one of the terms, and we're going to focus on the plus 48x, okay? The way that we're going to get the 48x is when we do the bx times the negative 2 times the negative 2. This bx, the middle one, times the negative 2 and the negative 2. And this third bx times the negative 2 and the negative 2, because those are going to give me the x terms. And if I add all these up, there's going to be 4bx, 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 which is 12bx. It's easy enough to solve from there to say that if 48x equals 12bx, then 4x has to equal bx, and b has to equal 4. And that will be our factoring. It's going to be 3x squared plus 4x minus 2 to the 3rd will be the factoring on that one. The second problem I wanted to talk about today was 2.5, and we had 8x plus 8 to the x plus 1 equals 144. Remember, you had to solve this without a calculator. If you had your calculator available, you could just graph this, no problem, graph it, see where they intersect, y1, y2, and get the answer right away. But we don't have the calculator, so we're going to use some factoring techniques. I'm going to factor out 8 to the x. When I factor out 8 to the x, that's going to leave me with 1 plus 8 to the 1, because 8 to the x times 8 to the 1 is 8 to the x plus 1. Okay, so 1 plus 8 is 9. I'm going to divide both sides by 9, and we're left with 8 to the x equals 16. Now, once again, if you had this under different circumstances, you might say, all right, graph this, take the natural log of both sides or whatever. But we don't have a calculator, so what we're going to do instead is we're going to rewrite both of these with the same base. We're going to write 8 as 2 to the 3rd. That's 2 to the 3rd to the x, and 16 is 2 to the 4th. Then we can say 2 to the 3x, because properties exponents, we multiply those, equals 2 to the 4th. And finally, we can say 3x equals 4, because if the bases are the same, the exponents have to be the same as well to get an answer of x equals 4/3. Remember, it's important to be able to do these questions without the calculator as well. The last problem I want to take a look at was the rock in the basket problem. Now, the concept is simple enough. You've got 200 rocks, and what we're going to do is we're going to go from the basket, grab the first rock, go back. Grab the second rock, go back. Grab the third rock, go back. And eventually we're going to grab the 200th rock and place all of them into the basket. And the question is, how many feet do we need to walk in order to do this? And if you look at it and break this down, there is a pattern. The first rock, you walk 3 feet, and then you walk an additional 3 feet. So that's 6 feet. All right. For the second rock, you're going to walk 3 and 3, which is 6, and you're going to walk 6 back, which is 12. The third rock, you're going to walk out 9 and then back 9. And then that 200th rock, we're going to walk out 1,200 feet. I'm sorry, we're going to walk all the way out and back. And if we see the pattern here, the first rock 6 feet, second rock 12 feet. So the 200th rock, you're going to walk a total of 1,200 feet. So the question is, how do we do 6 plus 12 plus 18 plus 24 all the way up to 1,200 without the calculator? Now, there is good news, and that comes from Carl Friedrich Gauss. So when Carl Friedrich Gauss was 9 years old, he basically irritated his teacher because he did all his work too fast. So the teacher said, you know, you think you're so smart. Why don't you go? I'll add up the numbers from 1 to 100 and leave me alone. All right. And different stories tell this differently. Some say by the time he walked back to his desk, he turned around and said it's 5,050. Some say that he went and sat for a second, never picked up his pencil and said it was 5,050. And then the teacher angrily confirmed that answer. But what he did was he used a pattern, and he said that basically that if you line up the numbers from 1 to 100, and then you line them up backwards underneath, that each pair, 1 plus 100, is 101. 99 plus 2 is 101. 98 plus 3 is 101. And you have 101, and you end up having 101 100 times. All right, 101, 101, 101, 100 times. But in doing that, that adds up all the numbers twice. So if we do half of 100, which is 50 times 101, is 5,050. And he figured this out at age 9. So we're going to use the same idea to add up those numbers that we wanted to from 6 to 1,200. Okay, so the way we're going to do that is this. We're going to think of this the same way. We're going to say we have 6 and 12 and 18 all the way out to 1,200. And if I place the same numbers underneath, 6, 12, 18, all the way back to 1,200, I'm going to end up with 1,206 plus 1,206 plus 1,206. And since, remember, there's 200 rocks, I'm going to have 1,206 200 times. Now, it's easy enough to do this calculation. 200 divided by 2 is 100, times 1,206 is 120,600 feet that we're going to end up walking, which is a big amount, but it's nice to be able to do things like this. Now, in general, the way that you do this is it's the first term plus the last term times the number of terms divided by 2. So that is the formal formula for it. But as long as you understand the process, then you're going to be in good shape. I hope this helped. Hopefully we'll get more 5s and 6s on the next quiz, and I'll see you guys soon.